The last section deals with solving equations and inequalities with absolute values. What is an absolute value? What does it look like? Very good. What does it tell us? What does it mean? What does absolute value refer to? The distance a number is from zero. It doesn't matter which direction from zero. In other words, the number positive 3 and negative 3 are both the same distance away from zero. The absolute value of negative 3 is 3. The absolute value of positive 3 is 3, because they're both 3 units away from zero. What would that one be? That's supposed to be a. What would that answer be? Negative 3. Order of operations. Special operations first. What's the absolute value of 3? 3. What's in front of it? Negative, yeah. In other words, this absolute value doesn't affect that one. There's a difference between those two. So the absolute value of x equals 5. What would x equal? Very good. It's plus or minus 5. This is very important. Whenever you drop the absolute value, you have to put the plus or minus in front of the answer. Whenever you drop the absolute value. Why? Because all this is asking is give me a number that's 5 units away from zero. The answer is negative 5 and positive 5. That's very important. How about this one? Same thing we do with square roots. Has to be isolated. Here's the reason why. The formula for square root is that. That's the formula for a square root. It is a radical. It's a square root. Don't believe me? Well, what's the absolute value of negative 3? Let's look at it this way. This is my x value. So square root of negative 3 squared. What is negative 3 squared? What's the square root of 9? So it's the same thing. Because what an absolute value does, it gets rid of the negative. Well, that's what the square does. When you square a number, it becomes positive, and then you square root. So first thing we have to get rid of here is what? How? Add 3 to both sides. X plus 2 is equal to 5. Now what? We're solving for x. How do we get to x? How do we get to x? What about the absolute value signs? What do we do with those? That's what we just did here. From here to here, we got rid of them, and that became a plus or minus. So when we get rid of the absolute value sign, we have to put a plus or minus in front of the answer. We can't get rid of anything else. There's only stuff inside there. So now we look at both sides of these numbers. We have x plus 2 equals positive 5. X plus 2 equals negative 5. We have to look at both of these numbers. So subtract 2. So x is equal to 3, and x is equal to negative 7. And of course, you check your answers the same way. If x is 3, 3 plus 2 is 5. Absolute value of 5 is 5 minus 3. So that one works. Negative 7. Negative 7 plus 2 is absolute value of negative 5. 5 minus 3. They both work. Always check your answers. So this is the important part here. Whenever you drop the absolute value, you have to look at the plus or minus of it. What about absolute value inequalities? Absolute value of x is less than some number a. So if we had some number a here, remember, absolute value is how far it is from 0. So if the absolute value is less than a, we also have to have another side here, the negative a. And it's going from here to here, so this one has to go from here to here. So whenever you have the absolute value of a less than symbol, and what happens is when we drop the absolute value sign, then we're looking for all the x's between those two numbers. So here's the formula for the less than symbol. How about the greater than symbol? Here's 0. If here's some number a, if x is greater than a, that means it's going away from it, right? It's getting bigger than it. But what about the other side? It's going to infinity. So this one has to go to negative infinity. So if you have an absolute value with a greater than symbol, the answer is going to be x is greater than a, or x is less than negative a. It has to go opposite directions. It's going away from 0. So those are your formulas. absolute value of 3x plus 2 is less than 5. Is the absolute value isolated? Yeah, there's nothing in front of it or behind it, no plus or minuses, so it's isolated. That's the first step. Is it isolated? Check. Now we can drop the absolute value sign. If we drop the absolute value sign, remember, it's a less than. We have to look at the plus and minus. So what's it going to look like? Well, here we have less than, so it's going to look like this. Whatever the answer is, will be on both sides. So it's going to be -5 is less than whatever this is less than 5. Okay. When you have an absolute value is less than a number, then that one, whatever's inside the absolute value, will go in the middle. And the number will go on both sides. Now we solve for this one. Get rid of the 2 first. So subtract 2 everywhere. So it's -7 is less than 3x is less than 3. Divide by 3. So it's -7/3 is less than x is less than 1. Remember, we can also put it this way, since they're inequalities. Five minus 2x is greater than equal to 1. Is the absolute value isolated? Yes, there's nothing in front of it, behind it, above it, below it, nothing plus or minus, nothing multiplied to it, nothing divided, so it's isolated. Remember, the rule we'll be using is this one. If it's greater than, if you're using a greater than, when we drop the absolute value, it's going to be greater than or less than the negative. Yes. It doesn't matter if it's the same thing. It's just if it's equal to, then just put equal to in there. Since they're greater than, then we can have whatever's inside here is my x. So it's 5 minus 2x is less than equal to -1, because it'll be negative of that answer. This is x, and this is a. Or this is my x, so it's 5 minus 2x is greater than or equal to a. Now we solve it. So we have subtract 5 from both sides across the board. So -2x is less than equal to -6, or -2x is greater than equal to -4. Remember our rules about changing signs and inequalities? So I change the sign, I change the direction, and I change the sign. So it becomes 2x is greater than equal to 6. or 2x is less than equal to 2, or x less than equal to 4, I'm sorry. Now we divide by 2. So x is greater than equal to 3, or x is less than equal to 2. And if you graphed it, so it'd be greater than equal to 3, or less than equal to 2. Check, it works out. Any questions about those? How about this one? No solution. Absolute values cannot be negative. So we can't go any further. Okay, that does that section, does that chapter. We're done with chapter 3 now. Yeah, that was super sweet. Because now we're going to do next, starting on Wednesday, we'll start chapter 4. Chapter 4 is going to be the most difficult because it has a lot of moving parts. We're just dealing with so far with these examples in the last section, quadratic equations. Now we're going to look at equations that look like this. And so on and so forth. We're going to have much bigger degrees. We're going to be able to graph those. You can find me the x-intercepts, find me the y-intercepts, where it's increasing, where it's decreasing. That's next time.